Hello everyone. Today we are going to solve our next question on LeetCode. The question is candy. So the question is saying that there are n children which are standing in a line and we have to distribute candies among these n children. Now this rating array is saying that each children is provided with some rating value and you have to distribute the candies among these children on the basis of these ratings. And these two conditions are given. These two conditions should be satisfied. The first condition is saying that each child must have at least one candy. Means you cannot give less than one candy. You cannot give zero candy to any child. Each child must have one candy at least. And the second one is children with a higher rating get more candies than their neighbors. And after that, we have to return the minimum number of candies that you have to distribute to the children. So how we can solve this? So let's see. Let's take an example to understand. Let's say this is the example. Now let's start distributing the candies. Now the minimum number of candies that you can give is one. So first here you will give one candy to it. This is a rating array. This is rating given to each and every children, and here you are distributing one candy to this first children because you have to try to give as minimum as possible candy to the children. Now it is two. The rating of this second children is two. You cannot give it one candy as it is greater than the neighbor. So here you will give two candy. Similarly, here you cannot give two candies because it is greater than its neighbor. So here you will give three candy. So the total number of candies in that case will be five. Sorry, six. Now let's try to take one another case and try to understand this. Let's take this example. So ratings are given like 1, 0, and 2. Now let's start from the first index. Let's start from the first index, and the minimum number of candy that you can give is 1. So now we are only considering for the left one. We are only considering for the left one in the first go. So if we will see in this left, there is no element. So simply we will give one candy to it. Now it is the smaller element. It is a smaller element. In that case, we can give because for now we are considering only the left ratings, only considering the left ratings. For this two, as it is greater, so basically we cannot give. It is greater than its left, so we cannot give one candy to it. We have to increase the number of candies. So here we can give two candies. Now let's start considering the right one. So if you will start from this element, then to its right, there is no element. So what we will do, we will simply give as minimum as possible candy to it. So it will be 1. Now, if we will come to this, then the rating is 0. So it is basically lesser. So we will consider the right one only. So we can give one candy to it because the minimum number of candy that we can give is 1. Now 1 is greater than 0. 1 is greater than 0. So now for this time we are considering the right one. So basically we cannot give one candy to it. We have to increase the number of candies. So we can give two candies. Now to satisfy both right and left, basically we have to take the maximum out of it. We have to take the maximum out of this left and right. So between them, the maximum is 2. Between them, it is 1. It is 2 equal to 5. And this is the answer. So now let's try to solve this. So this is the example we are taking to solve this. And let's try to first dry run on it. So as we can see here, first we will consider all the lefts. After that, we will consider all the right. And after that, we will get maximum out of it. So in this example, if we will see, the minimum number of candy that we can give is 1. So here we will give 1. After that, this 2 is greater than 0 as it is just this 0 is on left of 2. So basically we have to consider left for the first time. So we cannot give one candy to it. We have to increase the number of candy. So here we can give 2 candy. Again, this 4 is greater. So here we can give 3 candy. Now this 3 is smaller. 3 is smaller. So in that case, we have to give less as minimum as possible number of candy. So here we can give 1 candy because we are only considering the left for the first time. That's why we are trying to give as minimum as possible candy. Here it is 2 lesser than 3. So here we will give 1 candy. Similarly, we will give 1 candy here. And similarly in this case. Now this 3 is greater than this one. So in that case, we have to increase the amount of candy. So we can give 2 candies here because it is greater than this one. After that, this 5 is greater than 3. So we have to increase the amount of candy. So we can give 3 candy here. Similarly, we can give 4 candy here. Now this 4 is smaller than this 6. So in that case, we have to decrease the amount of candy and we will keep the minimum one, that is 1. Similarly, we can give 1 here and 1 here. So this is when we will consider only the left ratings. Now let's consider the right ratings and try to get it. So here we can see the minimum number of candy that we can give is 1. Now it is equal, so basically we can also give 1 here. Now this 4 is greater, so in that case we have to increase the number of candies, so we can give 2 candies. The 6 is greater, we will give 3 candies. Now this 5 is smaller, in that case we will decrease the number of candies to 1. Similarly, we will give 1 candy here, 1 candy here, and 1 candy here. Now this 2 is greater than 1 and we are considering the right one. So in that case, we have to increase the number of candy. It is 2. Again, we will increase. It is 3 and 4 and it is lesser. So we will give 1 and 1. Now, if we will see for a particular element, this for the 4, basically to satisfy this 4, what we have to do? We have to satisfy it for the right elements and we have to satisfy it for the left element. So for this, we will take the maximum out of this left and right. So between them, the maximum is this 4. So between them, the maximum is this 4. So we will do this. Now the answer will be the maximum of them. Here it is 2, 4, 3, 2, 1, 1, 2, 3, 4, 2, 1, 1. And if you add all these elements, then that will be the answer. So now let's try to write the pseudocode for this. So what we can do? First, we have to take two arrays, that is left and right, because first we have to extract the left elements. After that, we have to extract the right elements, and then we will get maximum out of them and add it to the sum. So let's try to solve this. So there is a function which is taking this ratings as a parameter. After that, what we will do? We will take two arrays. First, we will extract the length of this ratings array into a variable. That is ratings.length. After that, we will take two array. Left, which is of size n, and right, which is also of size n, which is equal to the size of this ratings array. After that, we know to the extreme left, there is this 0, and there is no element to the left of this element 0. So for the first element, we can always start with 1. So the left of 0 is equal to 1 in that case. Left of 0 is 1 in that case. And we also know that for the right one, at the extreme right, this is 0. And after that, there is no right element. So here we can also give 0. 1. So right of n minus 1 is also equal to 1. Now what we will do? Now first start traversing from the first element and go till the last for populating this left array. So what we will do for int I equal to 1, I lesser than n, and I plus plus. And what we will do now, we will compare whether if ratings of I, if ratings of I is greater than ratings of I minus 1. If ratings of I is greater than ratings of I minus 1, that is, this element is greater than the previous one. In that case, what we have to do? Basically, we have to increase the number of candies. So what we can do? We can put this left of I equal to left of I minus 1, the previous element, and we have to add 1 into it. Whatever the result of previous element, we have to add 1 into it. So it is left of I minus 1 plus 1. So this is how we can do this. Else, what we will do? As we will put this left of I equal to 1. Equal to 1. After that, now we have populated this left array. Now we will go to the right array. And what we will do? We will start traversing from this second element at the last second element. And we start traversing from this element for int I equal to n minus 2, I greater than equal to 0, and I minus minus. After that, what we will do? We will check whether this ratings of I is greater than ratings of I plus 1. Ratings of I plus 1. If this ratings of I is greater than ratings of I plus 1, then what we will do? We will simply increase the 1 into it, because if we are getting the right element, let's say in this case, this 0 is smaller than this 4. So if we will come to this 4, then we have to increase 1 into this result. So here what we will do? We will do right of I equal to right of I plus 1 plus 1. As what we will do, as we will put simply right of I equal to 1, equal to 1, right of I equal to 1. After that, we will come out of the loop. And finally, what we will do, we will loop through the array. We will start from 0, I lesser than n, and I plus plus. And what we will do, we will compare between the left and the right element, and which one is greater, we are going to add it into the sum. So we will take a variable sum here, initially, which is equal to 0, and we will check if we will try to extract the maximum out of both, and we will do sum plus equal to maximum of left of I, comma, right of I. And this will give us the answer. After that, finally, we will return sum. Now let's try to code this. What we will do first, we will extract this ratings dot length into a variable. After that, we will take two arrays of equal size equal to ratings, left equal to new int of similar size. And we will take right one of similar size. After that, we will make this left of 0 equal to 1 because it is the extreme left, and after this, before this, there is no element, so we will simply keep it as 1. And similarly, for the extreme right, we will keep it as 1. Now we will loop through this 0, I lesser than n, I plus plus, and we will loop through first element. We will loop through first element because of the element at first index, because we have already declared this element at 0th index as 1. Now what we will do, we will check whether this ratings of I is greater than ratings of I minus 1. If this is the condition, then what we will do, we will simply make this left of I equal to left of I minus 1 plus 1. We will increase the value by 1. As we will simply put this left of I equal to 1. Now again, we will do the same for the right one. We will loop, start loop from n minus 2, that's last second element. And after that, we will move till I is greater than equal to 0 and I minus minus. And we will check whether this ratings of I is greater than ratings of I plus 1. If this is the condition, then if this is the condition, then we will simply put this light of if this is the condition, then we will put simply this light of I equal to right of I plus 1 plus 1, and else we will put this right of I equal to 1. After that, finally, we will come here this place and we will loop through the whole array. And what we will do, we will take a variable sum, which is initially equal to 0, and we will try to extract the maximum out of it, out of left and the right one. From the left array and the right array, we will try to extract the maximum, and whichever is maximum, we will simply add it to the sum. So sum plus equal to mat dot max of left of I comma right of I. And after that, finally, we will return sum from here. Let's try to run this. Accept it. Submit. Okay, accept it. Now, if we will see in the solution, then the time complexity we are taking is the time complexity in this case we are taking is O of 3n, because we are looping it for 3 times. For first time, we are looping it for extracting this left array. And for the second time, we are doing it for right array. And after that, we are looping it to get the maximum out of these both arrays. So the time complexity is O of n, O of 3n. And the space complexity we are taking as here we are taking two arrays which are of equal length as the ratings. So it is O of 2n. So now let's try to optimize this. Let's try to optimize this. Now here we can see that we are taking we are looping for two times. First time we are populating the left array. For the second time we are populating the right array. But there is no need to populate it for the second time. When for the second time, what we can do is when we are calculating this sum, at the same time we can extract this value from this right and add into the sum at the maximum value out of left and right into the sum. So what we can do here is first let's remove this. Let's remove this. And now there is no need to take this right array. No need to take this right array. So we will remove this right array from here. And instead of taking this right array, what we will do is we will simply take a variable, a constant variable right, which is initially equal to 1. And we will take one more variable that is current. We will take one more variable that is current, which is initially equal to 1. And after that, what we will do, as we have to extract the sum, so we will take a variable sum, which is initially equal to 0. After that, we will loop. We will start looping from this I equal to n minus 2 from the last second element because we have to extract all the right. So we are starting from this last second element and we will go till I greater than equal to 0 and I minus minus. And what we will do is we will check whether if this ratings of I is greater than ratings of I minus 1, greater than ratings of I minus 1, then in that case, what we will do? In that case, we will simply increase the value of current because current is initially representing this second position, last second position. So current is initially representing this last second position and right is 1 because the extreme right element is always 1 because there is no element after this. So it is always 1. That's why we are taking this right as 1. And this current is equal to 1 initially, which is representing this. So we will simply add this current, this plus equal to 1. We will add 1 into the current plus equal to 1. Current plus equal to 1. After that, we will make this right as current, right equal to current because we have to decrease this right pointer as we are taking only a single variable and this single variable is here tracking the whole array. So here we have to make this right as current. Else what we will do? Else simply we will keep this current equal to 1. Simply we will keep this current equal to 1. And after that, what we can do? After that, we can check whether this we will as we have to add the maximum of left and right into the sum. So we can simply do sum equal to and we have to add it into the sum continuously. So we will do sum plus equal to math dot max of left of I. We will check for the left element and current and whichever is greater. So here I'm writing the rest of the code. So whichever is the greater between them, we will consider it. After that, we will come out of the loop. And now we have left with one condition because here we are started looping from this last second element. So we are not seeing for this element and it is 1 in that case. So what we will do as this right is 1 initially because after this element there is no element. So as we have to start with 1 always as minimum number of candies that we can give is 1. So what we can do at last we will check for a condition that and we will add it into the sum that mat.max of 1 comma this left of n minus 1 left of n minus 1. We will add it to the condition and after that finally we will return this sum out of it. Let's try to code this. So what we will do here is we will delete this right from here, delete this right from here. After that we will delete this loop and what we will do we will take two variables. One is right, which is equal to 1 initially, and this current is also equal to 1 initially. After that, what we will do is we will start looping from the second last element, and we will go till the 0th index and I minus minus. After that, what we will do is we will check for the condition that if ratings of I is greater than ratings of I plus 1 at any point of time, then what we will do in that case, we will simply increase the value of current by 1. Value of current by 1. We will simply increase the value of current by 1. And what we will do after that, we will make this right as current. Make this right as current. Else we will simply put this current equal to 1. And after that, we will check that whichever the element is greater, either the left or the right. So sum plus equal to math dot max of the left element, comma, current. And then we will handle this case where we have to check for the last element. So we will simply check and we will add sum plus equal to math dot max of, as the right is 1 here. So it is between 1 and left of n minus 1. And finally, we will return this sum from here. Let's try to run this. It is accepted. Submit. And accepted. Now, initially the time complexity was O of 3n. Now we have decreased it to O of 2n because now we are looping for 2 times. For the first time, we are extracting all the left elements. And after that, for the second time, what we are doing, we are extracting the right elements and comparing between the left and the right. Which one is greater? We are simply adding it to the sum. And after that, finally, we return the sum. And if you will see the space complexity, this is the time complexity that we have reduced. And the space complexity is now, initially it was O of 2n. Now it is O of n. So now we can further optimize this and make this space complexity as O of 1. Now let's try to do this. So here, this is the example we are taking. And now what we can do is, so there's a slope approach to solve this question. How it is? So what we can do is, basically we can represent all the elements into it in the form of slope. So let's represent it in the form of slope. Now first, initially it is 0. After that it is increasing, so it is 2. Then it is 4, 7. Now it is again decreasing to 6. Then it is 5. Then it is 4, 3, 2, and 1. Now there's a flat surface from this position to this. So there's a flat surface. It is 1 and 1. Again it is increasing. 2, 3, 4. Again decreasing. 2, 1, 1, and 1. So this is how this array can be represented in the form of slope. Now what we can do here is, let's see. Now the minimum number of element that we can assign is 1. The minimum number of element that we can assign is 1. So for this element, we are going to assign 1 here. After that, as the slope is increasing, so we have to increase the number of candies. So here we will assign 2. After that, we will assign 3. And finally, we will assign 4. Because from this point, this slope is decreasing. So here we are defining this 4. Now again, if we will try to assign this 1 into it, because as it is decreasing, so it is 1, 2, 3, 4, 0, minus 1. But we cannot do this. Why? Because we can be at least the minimum number of candies that we have to give is 1. So we cannot do this. So what we will do instead of this, now in the answer we have to tell the total number of candies we have to distribute. We do not have to tell that how we will distribute these candies. We have to tell the total number of candies. Now if we will see that if we will start from this position, then it is the minimum number of candies that we will give here is 1. After that 2, 3, 4, 5, 6, and this 7. At this edge it is 7. Okay, so here we have to tell the total sum of candies that we can give. We do not have to define that how much candies we have to give for each ratings. So here we have to provide the sum. So instead of taking it like this, we can simply take it like this: 1, 2, 3, 4, 5, and 6. It is also valid. Why? Because either we will take this sum as 6 plus 5 plus 4 plus 3 plus 2 plus 1, or either we will take it as 1 plus 2 plus 3 plus 4 plus 5 plus 6. The result will be equal. So what we can do here is, we will simply, as the slope start decreasing, what we will do, we will simply start assigning the numbers from 1, and we will increase the number from 1 to 6 till the time the slope is decreasing. So as we know that this is the last element 6, so if this is the last element, then the peak will be 1 greater than the 6. So here the peak is 7. So either we will give it as 6, 5, 4, 3, 2, 1, or we will give it as 1, 2, 3, 4, 5, 6. The sum will, finally the sum will definitely be equal. So we can give it in any way. So what we will do in that case, we will simply give this sum as 1, 2, 3, 4, 5, 6, and which makes this peak as 7. Now we have to choose between this 4 and 7, that whichever we can take. So if we will start from here, we are getting 4. And if we will start from here, as this is the 6 at the last, then the peak is 1 greater than it, which is 7. Now between these 4 and 7, we have to take the larger element. We have to take the larger element to satisfy the condition. Because if we will take 4 here, then this 4 is not going to satisfy this slope, this decreasing slope. And if we will take this 7, then this 7 will satisfy both the left slope or the right slope. So here we will take 7 out of them. So how we will solve this? We will take a sum variable. We will take a sum variable. And what we will do? First, as we are at the first element, so we will add this 1 here. So it is 1. Again, this is an increasing slope. So here we will add 2 into it. After that, we will add 3 into it, then 4. And at this 4, we are at the peak. So now what we will do? From here, there's a decreasing slope. So what we will do? Again, we will take this 1. So it is 1 plus 2 plus 3 plus 4 plus 5 plus 6. Now between this 4 and 7, we have to choose 7, as 7 will satisfy both the left slope and the right slope. So in that case, what we will do, as we know this peak is 4. This peak is 4. Because if we will start from here, then this is the increasing slope. And in this increasing slope, this is the peak. So simply we will take this element as peak. Simply we will take this element as peak. And after that, there's a decreasing slope. So it is decreasing from this to this 6. So finally, that down will be 1 greater than this last element 6. So it is 7. Now we have to choose between this 4 and 7 at the peak. And as 7 is greater, so it is satisfying both left and the right one. So we have to take this 7. Now as we are calculating the sum here, we have added this 1 plus 2 plus 3 plus 4 for these elements. And after that, this 1 plus 2 plus 3 plus 4 plus 5 plus 6 for the decreasing slope. But instead of 4, we have to add 7. So as we can see that if we will do down minus peak, that is 7 minus 4, which is equal to 3. So we have already added this 4 into our result. We have already added this 4 into our result, as we are on the increasing slope. Here we have added this 4 into the result. But we have to add this 7 instead of this 4. So what we can do, we will simply calculate down minus peak, which is equal to 3, and we have to add this 3 more into the result. So after that, we will add this 3 more into the result. So this will give us the answer for this much of part in the array. This much of part in the array. After that, there's a flat surface. For the flat surface, we can simply give this element as 1. So we will assign 1 to it and 1 to it. Why? Because here we are arranging the elements to satisfy our conditions. Technically, these elements should be like 6, 5, 4, 3, 2, and 1. So technically, these elements should be like this. So if we will see for this first element, the right element is also equal to this element. So we will give 1 here, and simply we will give 1 here also. So after that, what we will do, as it is a flat surface, so for this flat surface, we will add this one into the result. So we will add this one into the result. And after that, from here, again, we are starting traversing up because it is a increasing slope. So here we will give 2, then 3, then 4. Now there is a decreasing slope. So instead of taking it as 1 and 2, we will simply take that 1 and 2. And as per this element, as per this last element, the slope in this case will be this 3. The slope in this case will be this 3. So what we will do, we will simply add this 1 plus this 2 plus this 3 and this 4 into the result. And after that, as we can see, this increasing slope is giving this 4 element on the peak, and this decreasing slope is giving this 3 element at the peak. Now this is not satisfying the condition that down is greater than peak. So here there is no need to take the this down minus peak and add it to the result, because this increasing slope is giving us the greater element. So in that case, we will simply add this into the result. After that, we will take this 1 and 2 and add it into the result. And after that, finally, there's a flat surface. So technically, this should be 2, 1. So as this is equal to this one, because there is a flat surface, so we will also assign 1 and 1 here also. So it is equal to 1 plus 1. So this is our final result, which will give us 50. So now let's try to solve this. Okay, initially we will extract the length of this ratings array into a variable. After that, we will take some variable equal to 1 initially, and we take pointer I equal to 1, because we have to check every time with the previous element. Now we will loop through the array, and we will check whether the ratings of I is equal to ratings of I minus 1. Here we are checking for the flat surface. If there is a flat surface, what we will do, we will simply add 1 into the sum variable. After that, we will increase the pointer and continue. After that, we will check for the increasing slope. If I is lesser than n and ratings of I is greater than ratings of I minus 1, means there is an increasing slope. So for that, we have to take a variable peak, which is initially equal to 1. So what we will do is, we will increase the value of this peak to 1, add this peak into the sum, and increase the pointer. For the decreasing slope, we will take a down variable initially equal to 1. We will check for the decreasing slope. I is lesser than n, and then ratings of I is lesser than ratings of I minus 1. In that case, we will simply add this down into the result, increase this down, and increase the pointer. And finally, what we will do, we will check whether this down is greater than peak. If this down is greater than peak, then we will add down minus peak into the sum. Why we are doing this? Because in the condition here, we are giving these candies as 1, 2, 3, 4. So according to it, the peak element is 4. And if we will start from here, then 1, 2, 3, 4, 5, 6. The last element is 6, which is representing that the peak element will be 7, technically. So the maximum out of them is 7, but we have already added this 4 into the result. But we have to add this 7 instead of 4. So what we will do, we have already added 4. Now we have to add 7 minus 4 more into the result, which is equal to 3. So what this is what we are doing here. And after that, finally, we will return this sum from here. Let's try to run this, accept it, and submit. And accept it. So the time complexity it is taking is O of n. Now we can see that there are this is the while loop, and inside this there is another while loop. Still the time complexity is O of n, because for each and every element this will iterate for only one. Because if this is the condition where uh, there is a flat surface, then it will execute only one for those element. And if there is an increasing slope, then it will execute for each element in the increasing slope for one, and similarly in the decreasing slope. So the time complexity is O of n, and the space complexity, as we are not taking any extra space, so it is equal to O of 1. So that's all for today. Thank you.